In a few minutes, we will be starting by giving the floor to Dr. Mira Haddad. And if the technology is going to be taking longer, we should take the few minutes we have to get the speakers introducing themselves to make use of the minutes we have so that we will get started anytime the IT problem is sorted out. And I will be inviting Mrs. Mira Haddad to introduce from ICARDA, Jordan, to introduce herself and her field of expertise. تفضل.
Good afternoon. I hope you had a good lunch, everybody. My name is Mira Haddad. I am Jordanian working at International Center for Agricultural Research in dry land named ICARDA. And I'm working as a spatial analysis and database management research assistant. Yep.
Okay. Hello, my colleagues. My name is Ahmed from Egypt, and I am working as a manager for environmental affairs in holding company for water and wastewater. And in recent years, we are concentrated upon the climate change and its impact upon the water resources and water utilities. Thank you.
Dr. Ziad.
مساء الخير. Good evening. My name is Ziad Alawneh. I am from the civil society, and I represent Land and Human to Advocate Progress. It's an organization that works with local communities. And what I am going to be bringing along with my presentation, some of the local community experiences that would assist in overcoming the difficulties of ensuring having adequate amount of water. My background, I have a degree in public health, long experience. I work as a consultant with UNDP as well as with the Ministry of Environment. Thank you.
Good mix of profiles and experience we have. The holding company is a water utility, a big water utility in the region, actually serving in Egypt, a research organization, and a civil society. I think with this good mix of speakers, we are anticipating different perspectives on what are the risks and opportunities that climate change is going to be bringing to the region. If any of the speakers want to make a statement instead of a PowerPoint, that would be an option too, so that the audience...
It's working.
So it's okay? Yeah. Oh, yeah. So then we... Go ahead. Mrs. Mira.
I'm going to show you a case study that we did in Zarqa River Basin. It's one of the surface water basin in Jordan. This study has been conducted with Jordan University. Dr. Michel Rahbe and Maisa Shammout are from Jordan University. And with our colleague Firas Ziadat, he left ICARDA now and he's joining FAO. And Dr. Stefan Stromer is also my colleague in the office. I will give you this is the overview of my presentation. It's about the site. I will introduce you the site description. Then I will show you a little bit about the current status in the basin. Then I will show some of the analysis that we did for the rainfall based on in situ data. Then I will show you the results of the global circulation model analysis for the basin using precipitation and temperature with a specific model. Also, I will show you the results of SWOT modeling, which is the soil and water assessment tool. Then the results and the comparison between the two results. First of all, the Zarqa River Basin is located in the north of Jordan, partially in Syria. The watershed is approximately 4,000 square kilometer. The main outlet of the watershed the main inlet of the water in the basin is from Samra Wastewater Treatment Plant. The outlet of the basin, it's in King Talal Dam. The design capacity of King Talal Dam is 85 million cubic meter. And in the basin, we have large cities and industries, and this leads to siltation problem in King Talal Dam. This is the location of Jordan, which is east of Mediterranean Sea. And this is the small part, red point is the Zarqa River Basin. This is zoom in to the basin. Just to give you an idea about how much surface water structure existing in the basin and the groundwater wells, we have the dots. First of all, the dots is the wells, the groundwater wells in the basin. The green one is the ponds. Sorry for the legend, I'm not sure why it's not here. And the red one is Hafir, we call it Hafir. It's like a kind of water harvesting collection. And the triangle, blue triangle is the dams. And just this is the image here. This is the inlet of the Samra. This is the outlet of a Samra river basin. Of a Samra wastewater treatment plant. And this is the stream coming from upstream toward Samra to here. And also overview of the site. It's consists of different activities. Here we have Samra, which is almost in the middle of the basin. This is the Jarash Bridge. Maybe some of you are Jordanian and they know where is the Jarash Bridge. And this is King Talal Dam, which is the outlet of the water basin. After King Talal Dam, from here, the water goes to Big Wadi, to Ghor al-Urdun. We call it Jordan Valley. In the southern part of the basin, there is different industrial and residential areas. Here in the basin, downstream we have highlands with different agriculture practices. In the eastern part of the basin, it's really dry areas. We call it Badia. It received less than 200 millimeter rainfall, and there is different infrastructure in the Badia. And this one is this is a recent photo I took, 12 March, for a water collection bond in the basin as well. These are different pictures taken by the team of the study. This is an image just to show how it's in the highlands of the basin. There is like many orchard trees, especially olive trees. This is a photo in Spain, not in Jordan. Sorry for not taking photo for Jordan River Basin. This is just to show you how the extreme or heavy rainfall event can make the roots of the trees appear, and it's a severe impact. So just to tell you an idea about the project itself, it was like it done in collaboration with Ministry of Environment, Ministry of Agriculture, Ministry of Water and Irrigation. There was like a meeting, a group of experts met together to define the sustainable land management practices that could be adopted in the basin, which is, these are like the results of them: to use contour plowing in areas with rainfall greater than 250 millimeter per year, and in slopes less than 10%, and with the greater slopes we use stone wall ridges. Just to show you, this is the watershed area again, and this is the land cover land use. This map is based on Jawad al-Bakri work. He's from Jordan University as well. This here in the watershed, there is like orchard trees. This is the green one. This is, the sustainable land management practices suggested by the expert was based on already adopted technologies by the farmers in the region, which is the stone bunds. But these stone bunds give you less soil erosion, but it keeps the water in the farm, but you have less water in the stream, so you don't have water flow in the river. These photos from also the basin, different areas in Jarash. In general, just to tell you that if we have like intersection of the hill slope by the stone bunds, it keeps the water in the farm. It decreases the soil erosion, but there is like a problem. What is the water that coming out to the stream? We don't have water there, so we need to think in both ways. How can we keep water in the stream, and how we save water for the plants? So the case study first, we studied the rainfall pattern in the basin. We chose 24 selected rainfall stations based on Ministry of Water and Irrigation, and we chose the range of the years from 1968 to 2012, which is 45 years. Even there is much more rainfall stations in the basin. It's around 56 stations, but we used this based on the pattern, because some areas, especially to the west of the basin, we have many stations, especially Amman, Jarash. These are cities, so we have many rainfall stations there. So based on records, and we need it spatially distributed. So how did average annual precipitation and maximum daily rainfall changes? We did many analyses. So this is the distribution of, or the selected 24 stations. So this is the average annual rainfall. We did the kriging for the, the rainfall data we have, the 45 years. This is the rainfall isoheat map based on Ministry of Water and Irrigation. So according to our analysis, it's almost like similar together. If we can see here, it's like a dry areas, it's received less than 100 millimeter per year. And here up and down, the downstream of the watershed, it's receiving from 400 to 500 millimeter. Then we did the trend analysis of the precipitation. Here, if you see the green color of the kriging is showing you that there is a trend, positive trend, and the orange, it's a negative trend. But then we tried to find out the significance of this trend, if it is significant or not. So areas in the east part of the watershed, it shows significant trends. This is the average annual daily maximum. So it's the maximum day per year per the 45 years for each station, and it shows also consistent with the analysis above. But it tell you that there is extreme event receiving in this area, and it's mainly in Jarash, and part of Ajloun here, and down it's in Amman. It's the western part of Amman and Al Balqa Governorate. But also here, if you look here, that there is also like extreme events received in the eastern part of the watershed. This give you that even area with high rainfall, average annual rainfall, it received as well extreme events, as well as the areas in the desert. Okay, and this is again the trend and the significance of the average annual daily maximum. But here the color is the opposite. The significant as well, there is like significant increase of significant changes, in the average annual daily maximum in the in the western part and eastern part of the watershed. Here in the middle, we don't have that much significant. What is the conclusion based on the first analysis? That the average annual rainfall pattern is highly heterogenic. Average annual rainfall shows increasing and decreasing trends in different areas. By tendency, there is increasing in rainfall in high rainfall receiving areas in the west, and decreasing rainfall in low rainfall receiving areas in the east. Maximum daily rainfall pattern show maxima in west, high rainfall area, and the very east, which is lowest rainfall areas. Maximum daily rainfall trends to especially increase in mountainous west as well as in desert east of the watershed. So this means for us that we can say that it is erratic rainfall pattern. Now I will show you that we use the global circulation model. We used the rainfall data. The same rainfall data was processed and bias corrected based in two softwares, the Cordex to SWOT and Cordex to SWOT bias application. We used it to bias correct the regional climate models data. Data download from Cordex website, and the resolution of the data is it's 11 kilometer. And the model name is this, it's a European model. And the rainfall data bias corrected for two periods, 1970 to 2005, which is in the global circulation model, it's the history, and the future start from 2006 to 2011. Then the temperature data, unfortunately, we didn't have temperature data, but we downloaded this data from the same model, from also for the whole future period, 2006 to 2100. In general, there is 4 RCPs in the world, and all of them shows that all the RCPs models based on the concentration equivalent of the CO2. So, like for RCP 8.5, it shows that the human will continue use the fossil fuel, and there is will be always increase in CO2 production in the world. So it will be always increase. But RCP 6, which is there is a decline in the CO2 consumption after 2060, and RCP 4.5 shows that there is decline in after 2050 as well. And RCP 2.6, it's after 2.6 it's after 2050, but 4.5 it's there is a decline as well in 260, but greater than this one. Okay. The precipitation, the future scenarios, we try to choose one model that include 3 RCPs, and the model we choose has 2.6, 4.5, 8.5 scenarios, and it shows a spatially heterogenic pattern of increasing and decreasing annual rainfall amount and seasonal rainfall distribution. In the dry areas in the east, as well as some areas in the western mountains areas received less rainfall. Average annual rainfall decrease in central and southwestern area. For the temperature, the future scenarios, the same scenarios, shows increased temperature, maximum and minimum temperature +1, plus 1.3 degree in 2050 across entire watershed. This is the modeling of SWOT. We tried to modeling the rainfall runoff response and implications on Zarqa River Basin water balance, targeting surface runoff and sediment yield affecting the dam. So the climate scenarios that we try to map is the present stage from 1991 to 2010, then 3 climate change prediction. And we choose this 40 years just to have 40 years together, in the present stage, which is 91 to 2010 and 2041 to 2060. So I will show you now a map that compare the two together. Before this, this is the input of the SWOT. This is the land use or the management in the watershed. This is the soil. We used anybody from Ministry of Agriculture? Okay, we use the soil map unit in Jordan, but we map it to the 1 kilometer soil grid by Isaac. Then the terrain was 90 meter resolution, and this is the calibration because we use the data from Khirbet al-Samra wastewater treatment plant to King Talal Dam. Okay, so